tonight, okay? So we're gonna do the integration tonight. Integration. Okay, let's just come here, share the link with my beautiful familia. Linamatla, she should be here. Okay, let's just go. Yeah, right here, right here, right here. I hope you all can see me. All can hear me. Can you hear me, everybody? Can you hear my beautiful family? Yeah, they can hear me. They can hear me very clear. So let me just send the link to them. And I'm sorry. Okay, let me just share the link with my brother and sister. Okay. Just come here and share with Linamatla. Okay. Linamatla, and then another one. Okay, I see. Yes. Okay. The Kwanda. Okay, I want to make sure I share with everybody. Okay. Fernando. Okay, share with everybody. Okay. Okay, just share with them. Okay. Okay, the link went through. Okay. Okay, look, if you live right now, please let me know. Say, hey, I'm live right now. Let's get started. We ready. Just let me know that we can get started. Click the link. Let's get started. Click the link. Let's start. Do solve our questions. I hope. Okay, let me just refresh this page here. I want to make sure everything's in the right order. Yes. Okay, so if you're here, please let me know so we can get started. If you're here, let me know we can get started. So I'm just waiting for you guys to get started. Click the link. Let's get started. Click the link. Let's get started. I'm just waiting for you. If you're live, if you're online, just come through, and then we can get started. Okay. Okay. Let me know who somebody's watching there. Say, hey, I'm Chwana. I'm Lina Matle. Or I'm whoever. Okay. Or I'm Mayando, Sibongi, or anybody. Just let me know. Just write your name right there so I know who's watching and where you come from. Where you from? Your name right there under the link below. No, it's not a link. Right there in the live. Just click the link. Say, I'm here. Because I do this for you. Okay, you guys asked me, I'm trying to listen. Make some video. That's why I came here, right? So click the link. Tell me, I'm here. I'm right here. Just let me know where you're watching from, who you are, and then let's get started. We're gonna make this very short class, but it's gonna be very, very, very powerful, efficient. And hey, listen, come on, man. We had another class before this. Man, come on, man. If I tell you this, but hey, let's just go. I'll tell you at the end. I'm gonna tell you at the end when you finish the class. I'll tell you what happened before your class. Something happened with the previous classes. Okay. I'm just waiting for my family to come. Tell me, please, if you're here, let me know. Hey, Mchana, I'm here. So we can get started. Okay, because I only see 2 people watching right there. So if you're live, let me know so we can get started, right? Because I was just waiting for you guys. Okay, if you're live, hey, Innocent, memelam kai. Sure. Thanks a lot for coming through, my brother. So Innocent is here already. Okay, I'm just waiting for the other brother and sister to come through. Because this is going to be very short class, but it's going to be very, very efficient, powerful. Let me get started. Let's just make 2 minutes, and then we can get started. Hello, Innocent, say hello. Innocent Memela. Innocent, where you come from, brother? Where you watching from? Tell me where you watching from so we can get started. Tell me, either you from Johannesburg or you from Northwest or Free State or let me guess. I think you from Johannesburg. I don't think you're from Durban, because I have a lot of my friends from Durban, and most of them they have full. Okay, I'm gonna tell you the other time. I can't say it here on the live, but I think you're from Gauteng. There is no way you can be coming from KZN. I think so, I guess. Please let me know where you're watching from, Innocent. Okay, my brother and sister, let's get started. I'm just waiting for you guys. So let me get started. Since the other one is still coming, are dragging their feet, so I think I can get started. Okay, come on, Bob. How come you have Innocent? What is your first name, Machif? What is your African name? What is your African name? Because like Abandu Basekaya, like Banese, they always have like initial name, like African name. I'm just surprised. Okay, so the other one, I think they're taking time. Probably they're logging in. Let's just wait then for 2 minutes if it's not, and then we can get started. Just 2 minutes that we gonna start. Okay, we're gonna start. Then they're gonna watch maybe after. They're gonna watch post class. So let's get started. So let me just try to call Lina Matle quick. Lina Matle, I don't know what she at. I don't know what Lina Matle she at. Fernando, Lina Matle, Lina Matle, Lina Matle, Lina Matle. We're just waiting for you. Let us know if you're on live so we can get started. Okay. Just leave a comments right there. Let me know if you live so we can get started, Lina Matle. Cause you've been asking me for the whole day. I'm trying to want a class, so I'm here live. So let me know if you're live. Oh, I'm here, Lina Matle. She said I'm here. Lina Matle, Mabusela. Lina Matle, I think she's from Devon. It's obvious. Lina Matle, Mabusela. If it's not Devon, maybe I don't think it might. Oseni. I doubt. I think it's KZ10. Okay, now let's get started. So for that being said, we can get started with the classes. So we're gonna solve all this question right here. She told me I'm here with you live. So, Alina Matle, tell me where you're watching from. So let's get started with the first question. So before we get started with the question, I want to show you. So after we finish this video, we're going to be able to solve all these questions. This one right here, and this is a word problem of integration. All these questions we're going to be able to solve. All of this. All this question. Consumer surplus. The consumer surplus and integration, application of integration. All of these we're going to be able to solve. Okay, so first, let me show you the basic of it. No, let's just go straight to the question. Which question to start with? I would like to start, which is the same thing here. Yeah, let's do this one here. So, look. East London, Eastern Cape. Lina Matle, close. Huh? Oseni. All right. Let's get started. Okay, so, let's get started. So look, let me show you the basic face of integration, right? This sign here is integral. Some people write like that, or you can write like that, like a snake or something. That's an integration. So we have a rules of integration, right? Let's check some rules of integration face. So I'm gonna go quicker, but I'll make sure that you understand. And you can stop me anytime. Say I'm trying to stop, I'm trying to repeat, but let me do a lot of example face, and then you're gonna ask me the question, okay? So let's check the face rule. If you have, let's say, x power n d x. This is a power rule of integration because you have your function and it has a power. So what you're going to do here, right? You only take this one here, say x power n, and then plus 1 over the same thing, n plus 1. And then you plus your c. Reason you plus your c, because we don't have a constant right there. And now I'm going to show you what does that mean. For example, somebody give you, let's say, integral of x power 4 dx. So this same say, right? X, take this 4 plus 1 equal to 5. Leave integral, leave dx, let them disappear. And they say x power 5, the same thing which is here, right at the bottom. And then you plus your c. They see because we don't have a limit. I'm going to show example whereby we have a limit. Let's take 2 more examples, and then we can solve our question, right? Let's take some rules here. Lina Matle, she say, I'm from East London, Eastern Cape. East London. I've got a lot of my friends from East London, and KZ10. A lot of my brother and sister from there. Okay, here we go. So now somebody give you, let's say, x power let's say 4 and then dx. Let's do it like this. No, that's gonna be way easier now. Plus, let's say, square root of x, and then they say dx. So first and foremost, you can separate. It's very acceptable. So I'm gonna say integral the first one and the integral the second one. And another things, you don't want this to be in a root like that. It has to be in power. But hey, look, let's go back to your exponential. If somebody give, let's say, square root of x, this in math is the same as say, look, if there's no number here, they just square root of x. Means the number which is here is 2, even if they don't give to you. unless it's the right number. But they didn't give a number, just know it's 2. And then say this 2 over 1. So then what you're going to say, write your x, flip this number, say 1 over 2. So you have changed your root into power or into exponential. Remember that. Very, very important. Okay? I like this class because you guys show me some love, man. Not the previous class. The previous class, there was a lot of jealous people in headers, man. And they're my student too. I was like, yo, you guys don't, like, I'm telling you, man. Okay, let's go. Never mind. So now we say, if you have, let's say, before we solve the question, let somebody give you 3. So we know 3, put 1 under, because when you say 3 and when you say 3 over 1, it's still 3. So say, let's say somebody gives something like that. So if they give only 3 here, they're going to give stuff like this. Let's say 3. So before you start to integral, your number must be power. So this is going to be, write your x and then write this over 1 and then flip. It's going to be 1 over 3. One more example, and then we go and solve our equation. Okay? And then we're going to go and solve our question. Let's say somebody give another example. Let's say, okay, this is going to be, let's say, square root. Let's say x, and they give here 4. So 4 means write 1 under, and this is going to be x flip is going to be 1 over 4. Okay? So remember, if you have a root, make sure you write as a power. So there's no number here, means I'm going to say this is going to be 2 over 1. And then I'm going to say this, same as say x 1 over 2. Remember that. Okay? So then I'm going to place that x going to be x 1 over 2. I'm going to remove the root of say, because I don't have a space. That's why I want to write a lot of things. It's going to be x 1 over 2. So it's in power already. But remember there's a bracket. So then you can integrate separately. I'm going to say integral x, and then I'm going to say my 4 dx. Means this with the dx and the plus, and then I say integral of the second one, which is x 1 over 2 dx. So according to the power of integral, what you do, we only take that. Integral disappear, dx disappear. It means that you integrate. So then I'm going to say x, take 4 plus 1 equal to 5, and then divided by the same number, which is the power, which is 5. Here there's a plus, write your plus, write the same thing, x, a half plus 1. What is a half plus 1? A half plus 1 equal to 3 over 2. You can take your calculator if you don't know how to do that. Say a half plus 1. A half plus 1, because you must plus 1. Whatever you have here, plus 1. A half plus 1 equals 3 over 2. So I'm going to say this is going to be 3 over 2. And then you over the same number, which is here right at the bottom. 3 over 2. And then plus your c. The reason plus our c, because in our integral, we don't have a limit. I'm going to show example whereby we have a limit. But remember, if you have a fraction at the bottom, okay, what you do, take these 2 here. The one at the, if only if you have a fraction, do not do that if you have this situation. So oh, there's a 5 here, I'm going to take to the top. Never do that. Only if you have 2 numbers, like here, 3 over 2. Take the one at the bottom to the top here. So 2 is going to come here and then scratch this. So it's like, it's going to be 2 over 3 x power. So this is going to become 2 over 3 and then x. Okay, so I'm going to erase this to become 2 over 3, because that 2 is went up, and then plus c, and we're done there. And you have integrated that one to that one. Let's take more 2 examples, and then after that 2 more examples, and then afterward we're gonna go to our more integral. Another thing is called reciprocation. Reciprocation is very, very important, and is real life application. Look, if you do something to somebody, right, you expect when you're in trouble that person must help you. Okay? Yes. So that's what we call reciprocate. Reciprocate. I do for you, you do for me. You do for me, I do for you. Okay? So if you have, let's say, the reason I'm showing you this is because you're going to apply very, very soon. If somebody give you 3 x power 3 or negative 8, let's say, you can reciprocate this. What do you reciprocate the letter with the power? The rest of the stuff do not do anything. Means 3 is going to be 3, and then take, you see this one, the one? Letter and the power is going to go to the bottom. Everything go to the bottom of a number. So it's going to come here, x. So the only thing, you write exactly, but the only thing is going to change is the sign. Is negative, here is going to become positive. That's all. But if here is positive, here is going to become negative. You just change the sign. If it's on top, go to the bottom. If it's at the bottom, you go to the top. That's how you reciprocate. So even this one here, I can reciprocate 2 if I want. I'm going to say if I want to reciprocate this, I'm going to say 3, just a 3. And then I can take this to the top. So it's going to become x. But remember, this is positive. It's going to become negative 8. So you can reciprocate back and forth, back and forth. Let me check more example of reciprocation. Okay, let's say somebody give you, let's say negative 4 over 5, and they give you square root of x. They say reciprocate. So first and foremost, this is going to become negative 4, but there's a 5 here, right? But when you say x square root, what that mean? We know here there's a 2 here. There's no number 2 here. 2 and then over 1. You see what I'm saying? Like I said before, if you have a square root of, let's say, y, we know this is going to be 2 over 1 if they don't give any number. So I'm going to remove this root and write to the power. So I'm going to flip this. This is going to become x, just say x. And then when I flip, it's going to become 1 over 2. So now I can reciprocate. What do we reciprocate? We always reciprocate a letter with a power. The rest of the stuff, please do not do anything because that's none of your business. So then this is going to become, -4, just say -4 because there's nothing to do with the reciprocation. Only reciprocate letter with the power. So this is going to go here to the top. It's going to come into the top. It will become x. Remember, this is positive, this power. So this power, since it's positive, is going to become negative. -1 over 2. So you have already reciprocated. It was this one, now it became that. So if you don't understand, please let me know. But hey, look, that's how you reciprocate. Let's go to the question now. Why did I learn this? For a good reason. Let me show you why did I learn that. The reason why, because we learn integration, but why am I come for reciprocation? Why am I come to the power and exponent? Because this is for my brother and sister who want to learn. And I'm going to show you how we do it. Okay, for example, somebody give you, they say integrate, let's say 4x plus 3 square root of x. And they say dx. So first and foremost, I don't need the root. Because this one here, look, is 3 over square root of x. So this I'm going to say 3, but a square root of x, you know here, there's a 2 over 1. So this I'm going to say x, I'll flip it, it's going to be 1 over 2. And then this is equal, I can reciprocate this. I can take to the top if I want, means it's going to become 3. And then when this go to the top, it's going to become same number, but the only thing, the power is going to change because this power is a half, it's going to become negative or negative a half. Okay, we have already reciprocated. So if I don't want this, also I can reciprocate. Say, okay, well, which number is in here? Maybe this is 2 over 1. I can remove that square root because I don't need the root. So I'm going to say this is going to become 1 over 2. And the next things I can reciprocate means I'm going to take this one to the top. It's going to become 3x power negative a half. It's going to become 3x power negative a half because it went to the top. So when you have like that, then you can integrate. So that's why the reciprocation is very, very important when you integrate. So then I'm going to say, well, I can separate. So I'm going to say integral of the first one. What is the first one? 4x. So there's no power here, means this is power 1. So it's 4x power 1. So I will take 4 because 4 doesn't have an x. 4x power 1. You see what I'm saying? Means I take this before integral, x power 1, and then write your dx. There's a plus here, write your plus. Now we go to the next one. It's going to be integral 3x power negative 1 over 2. I'll take my 3 behind integral because 3 is a constant number, has nothing to do with the x. Integral, because integral for the first group, integral for the second group. But here the 3 is going to come before integral. Write your x power negative a half. Dx, dx. So right here, yes, we can integrate. We can integrate. So what we're going to do, look at this. So I'm going to take that plus 1. Because now we can integrate. We'll say 4, just say 4. Let me do this. Let me raise this here so I can have a space. So this 4, just a 4. And then this and this is going to cancel because I can use the power rule of integration. X, 1 plus 1 is going to be x squared because we must take the power plus 1. We must take this 1 plus 1. It's going to become 2. And the same number here divided by at the bottom. But for now, don't plus here because we got another group. So don't plus C for now. We plus 3, just a 3. We take this one now. X. Negative a half plus 1. What is negative a half plus 1? Negative a half plus 1 equal to positive a half. So this is going to become positive a half because whatever you have here, you must plus 1. And the same thing you write at the bottom. Same power you write at the bottom. Now we can plus C because we got nothing more. And the reason we plus C because we don't have a limit. You don't want to plus C on a face integral C. We don't need 2C, just 1C. So then we're going to say this is going to go to the top here. Okay? So then we're going to have what is 4 divided by 2? 4 divided by 2 equal to 2, and then x power square, and then you plus 2 times 3 equal to 6, and then x power half. Because this is going to come here, right? So it's going to become 2 times 3 equal to 6, and then over 1, and this is going to become a half, and then you plus c. But what is x a half? If you say x a half is the same as say square root of x, because you can flip it, and then you put this over 2 over 1, mean you can write is a half. If you have an x a half, means it's square root of x. If you have x 1 over 3, the same as say x root of 3, because you flip it, and then you write only 3. So that's what we have. And then, but if you have a 3 over 1 equal to 3, anything, even if you have a y over 1 equal to y. So if you have all this stuff over 1, it's going to be the same thing, which is 6x power half. But if you don't want to write this x power half, you can say square root of x. If you don't want to write, like say, square root of x. So same as say 2x power square plus 6 square root of x plus c. And this is going to be a final answer. Excuse me. Now, okay. Let's go check more example. Check more example quick here. The class is going to be very short. Okay, I think within 15 minutes we're going to be done with almost 7, or because I want to show you the concept, and then when we start to solve, it's going to be way easier for you. Another rule of integration, say, look, if you have integral of dp equal to p, integral of dk equal to k, integral of d mtwana equal to mtwana, integral of dx equal to x. Remember that, very, very important. Very important. Another rule, these are rules, right? You have to learn the rules. It's like when you go to school or you learn anything new, you must learn the rules, okay? You have to learn the rules. Anything, if you want to learn anything, you must learn the rules and regulation. Okay, now, if somebody give you integral, listen to this, this is very, very important. Integral of x, let's say power dx. So how do you solve this? First and foremost, okay, let's say this is 4. I'll take this 4 behind. I can say this MSA integral 4, just a 4, and then I'm going to reciprocate this, because when you integrate, this must be to the top. It's going to become x negative 2 dx. So the next things, I'll take the 4 behind. It's going to be 4, because the constant term, and they'll have x negative 2 dx. So the next thing here, what you do, take that 1 plus 1, because there's a power rule of integration. So this is going to become 4 is just a 4. Take your x. Let me write like this. No, that's not okay. This 4 is going to come. It's just a 4. Now this is a power of integration. So I'm going to say my x is just my x, because I'm going to integrate. Integrand dx is going to go, so it's going to be x negative 2 plus 1 equal to negative 1, because I'm going to take my negative 2 plus 1. Negative 2 plus 1 equal to negative 1. I'm going to write that. But anything which you write here on top, you must write at the bottom, and then you plus c. The reason plus c, because we don't have a we don't have a limit from the integral. I'm going to show you a question where you have a limit example. So then our answer here is going to become 4x power negative 1 over negative 1. But what is 4 divided by negative 1? Equal to negative 4. So I don't have to write 4 over negative 1. I can simply say negative 4, which I can write behind here. But here, look, plus c constant. But I don't think it's a proper way for us to leave a final answer like this. I don't think that's a proper way. So I can simply say this same as say 4 over, I'm going to put at the bottom as a reciprocation, because it's okay, that's the answer, but it's not proper way to leave an answer as a negative power. So I'm going to reciprocate. Let me write here. It's like, okay, let me write here so you can see what I mean. Make some spaces here, right? In 20-15 minutes, I want us to do like maybe 6 or 7 questions quick. These are just example, but we're going to start a question now, very soon, and you're going to understand. Okay, so this is our final answer, but I don't think this is a proper way of leaving a final answer as a negative power. So I'm going to say my negative 4 is just a negative 4, and then I'll take this to the bottom of a number, because our final answer to be negative is not good. We over, take to the bottom, is going to become x. Same thing, negative, but I do not write negative, change the power, make it a positive 1. So just say 1. Positive 1 means it's 1. I don't have to say the positive 1. Let's see if it's negative, then I have to say negative, then plus c. But anything power 1, it does something. If you say 3 power 1, it's just a 3. I don't have to say 3 power 1. So x power 1 is just an x. I don't need this power 1. So this is my final answer. Let's take example which has a limit now. example, which has a limit. My beautiful Linda Masha is there. No Kwanda, if you're watching live, please let me know if you're there. No Kwanda and everybody who doing integration basics or beginners, or the one who want to solve that question, which I put in the thumbnail. Tell me where you come from, where you're watching from, and click the like button. Here we go. Click the like button, and here we go. Now, another example which I want to show you. Now, this is tricky. It's not tricky. If you have integral of 1 over x, if there's no power here, it's just x dx. This is exceptional. Do not reciprocate. This is the same as say ln or lean. Some people they call lean, but I don't know, for some reason, since when I started learning integration, I always call ln. Some people say it's not ln Twana, it's lean. Alright, whatever you can call it, as long as you can solve it. Okay, so you're gonna say ln, and then you put your absolute, write this letter which is in here, right here, and then plus constant c. We plus constant c because we don't have a limit. So if somebody give me integral 1 over m dm. So how this is gonna become? This is gonna become ln over, right? Only if it's m. If it's 2, different case. If it's 2, if it's 3, if it's negative, whatever, you must reciprocate. Only when there's no power here. And if this m is at the bottom, then we're gonna say ln, and right here, and then we plus constant c. Reason plus constant c because we don't have no limit. Remember that ln. Okay, if it's 1 over 1 letter. Okay, let's take more example, just one example, and then we're gonna do the example with the limit, and then after we're done with the example limit, then we're gonna go and solve all this question, because you won't be able to solve any question if you don't know the rules and regulation of integration. Okay, and if you don't follow the rules, you're gonna be in trouble. You must follow the rules. Okay, you must follow the rules. So if somebody give you, for example, integral, okay, let's say 3 over 7 x dx. Oh yes, there's no power here, it's just power 1. So yes, I can say that's equal to ln. So but first and foremost, I'll take this number behind, because this number has nothing to do with the integration. They are constant. So I'm going to say this is equal to 3 over 7 integral 1 over x, because all these went behind the integral. So here's like a 1 over x dx. So for that being said, that's gonna be 3 over 7, but this stuff equal to ln. So I'm gonna say ln, which letter is here at the bottom is x, and then we plus c because we don't have a limit. Now let's do the example whereby we have a limit. Okay, let's do the example whereby we have a limit of integration. Let's do the example whereby we have a limit of integration now, because I've been talking about this limit for some time now, right? Let's take the example which has a limit. So first and foremost, I want to separate this integral. I apologize, my mic was acting up a little bit. Okay, I'm sorry about that. So let's say somebody give you this. So then first and foremost, I'm going to separate the integral. I'm going to say integral of m cubed dm, integral of 7 over m dm. Okay, so I'm going to say integral of the first one, which is m cubed dm, and then plus integral of 7 over m, integral of 7 over m dm. So then we know this is just a normal power of integration. So this is going to become m. Take the 3, which is the power plus 1. 3 plus 1 equal to 4 over the same number, which is the power here, plus 1. Plus 4, I mean. The same number. Okay, take the 3 plus 1 equal to 4. Right here is a power. And the same number, which is in here, right at the bottom. Plus with plus. Now you go for the next number. This 7 is going to go behind because it's 7. So it's going to be 7. And now it's like you integrate 1 over m. It's like a 7, 1 over m. But when you integrate 1 over m, we know equal to ln. Write your absolute. Which letter is here? M. and then you plus your c because there's a constant, okay? Now, let's assume, let's say there's a limit. Let's assume that there's a 1 and 2 here. So then how are we going to solve? If there's a limit which is start from 1 and 2, what we're going to do, we're going to say, well, our limit, you write limit at the end. You see what I do here? So you do not plus c. Never plus c if you have your limit. Never do that because you're going to be in trouble. You're really going to be in trouble. So I'm going to write my limit. What is my limit? My limit start from 1 to 2. They're going to give the limit at the end of integral. Let's say this is 1. Say limit integral 1 to 2 as a limit. So here I'm going to write 1 to 2. Now, let me show you how to substitute the limit. Always limit, take upper limit minus lower limit. Always upper limit minus lower limit. After this question there, we're going to solve our all question, which we have there. Okay? Excuse me. Then we're going to say integral. Oh, why must I say integral? We must say upper limit minus lower limit. Upper limit. So we don't plus c now. No, you don't plus c because they have a limit. So upper limit minus lower limit always. So what is the upper limit? Our upper limit is 2. So take these 2 and substitute wherever there is the letter. Substitute here, substitute there. That's all. So I'm going to do like this. It's going to be upper limit minus lower limit. Now we go. So whenever there's an m, I'm going to substitute the upper limit. Means the upper limit is going to be in here. So it's going to become 2. Remember there's a power 4. Power 4 over 4. This is 2 power 4. Okay, let me write here like this. Plus 7 ln. What is a m? M is 2 because we say we substitute the upper limit first. 2 everywhere there's an m. Minus lower limit. What is the lower limit? It's lower limit. So we're going to substitute this 1 everywhere there's an m in the whole question. Here there's an m, means in the position of m I'm going to put 1. But remember it's power 4 over right your 4 plus. Now 7 ln. What is our m? Our m equal to 1 now. And then you're done already. Now you can simply plug in the calculator and get one answer. Okay? But what is the ln of 1? In math, ln of 1 equal to 0. Ln of 1 equal to 0. You have to memorize that. You have to know that. Ln or ln of 1 always equal to 0. And I can plug in the calculator for me to verify my statement. So then you're going to say, no, he's lying. He always do his math from, I don't know where he get the formula from or which rules he apply. Let's just show here. Come here. Where's our ln? Our ln equal to this one and say 1 and then close the bracket. See what is going to happen. Yeah, 0. But also ln of e equal to 1. Look. So ln of 1 equal to 0. But if you replace this and then place with e means come to shift and then place that one right there and then power 1 means that's a ln of e. Look how it's going to say. Equal to 1. So ln of e equal to 1, but ln of 1 equal to 0. Let's go to the question and finish up. Let's go to the actual question now, which they gave to us. Okay. We have a question right here. This is a question we have. So they say solve it. So now for you to solve this question, you must know all the rules and regulation. Okay. You have to know the rule. Otherwise you won't be able to solve this question. So let me start with the first one. So the first one, I'm going to say, well, I can solve that. Let me start to, so I'm going to say integral of all this group. I'm going to put it like this. Dx. Let me integrate one by one. So I'm going to say, well, integral of 100 x 99 dx. So first and foremost, this 100 must go to the behind because that's a constant term. So I'm going to say 100 is going to come behind integral because it's a constant term, has nothing to do with the integration because the constant, so it always go behind. So it's going to be 100 goes behind because it's a constant term. And I'm sorry. Okay. So then after this, let me say, write your 100, just a 100, let's integrate because it's a power rule of integration. It's going to become x, 99 plus 1 equal to 100. And the same power which is in here right at the bottom of 100. So what happened now? This and this cancel. So our final answer for the first group equal to x power 100, which is this one. So now the first one is going to become what? X power 100. Let's go to the second one. Let's integrate the second one. So the game is going to be almost similar. This 20 is going to go behind and then I'm going to integrate x power 4 dx, because this 20 is going to go. Okay, now we go. So how are we going to do now? We're going to take 4 plus 1, 4. So we're going to write out 20, just say 20. Take this x power 4. 4 plus 1 equal to 5, and then divide by this 5. And then look, 20 divided by 5 equal to 4. So this, let me say 4x power 5. But remember here there's a plus, so I'm going to say plus x, 4x power 5. My apologies, 4x power 5. I'm going to say 4x power 5. Let's go to the next one. To the next one, oh, let me first move my calculator because it seems like my calculator kind of covered there. Oh, I'm sorry. Move the calculator to the right. Yes, I don't need anything. I only need the equation right there that I can solve. So, well, so I'm going to go to the next one, to the third one, to the third one. This is done. This is done. We'll go to the third one. The third one is going to be integral. These 2 over x power square. But look, what I'm going to do, I'm going to reciprocate this. I'll take this to the top. So this same is say integral 2x power negative 2, because this is going to come to the top, and this positive, when you go to the top, when you reciprocate, is going to become negative dx. So what happened here is we're going to say this equal 2 is a constant, so it's going to come behind, and this is going to become x. Negative 2 plus 1 equal to negative 1. And then the same thing goes right to the bottom. And this same is say 2 is just a 2, but 2 divided by negative 1 equal to negative 2. And now I can simply say this is negative 2. But look, I can reciprocate, because even though I'm done integration, but I can take this to the bottom, because even though negative 2x power 1 is the correct answer, but I don't think it's the right way for me to leave my final answer as negative power. So I'm going to say over means I'm going to write my 2 has nothing to do with the reciprocation. And then I'm going to say over, I'll take this to the bottom. It's going to be x power 1. But x power 1 is just x. So it's like negative 2 over x. So instead of writing this, you're going to write what? Negative 2 over x. We go to the next one. You go to the next one. Is this on it? My apologies. I'm sorry. Okay, so the next one's going to be this one. It's integral 3 over x dx. But look, this 3 is going to go behind. So this, let me say 3 integral. Here is going to be only 1 left over x dx. But we know this equal to ln, because like 1 over x. And we know this integral equal to ln. So I'm going to say 3 ln of this letter, so of x. Okay? But remember here there's a plus. So it's going to be plus 3 ln x. Let's go to the last one. To the last one, let's finish up the last one. Finish up the last one. So the last one is like integral of 9, but we must put our dx. 9 is just a constant term. It's a constant, so it's going to become behind integral of dx. But we said before, if you have an integral of d student, means equal to student, integral of dx equal to x. So integral of dx equal to x. So this can be 9x. So the last one, the space is 9 enough there. It's going to be what? 9x. Let me write my full answer on top there. 9x I'm going to write now. So here I must plus what? 9x. Let me write here. So this is going to be x power 100 plus 4x power 5 minus 2 over x plus 3 ln of x, and then plus 9x. But hey, look, remember, if you integrate this one, there's no limit here. So since there's no limit, it means you must plus c. So you must plus your c here. Okay, let me write again so that you can see everything, because it seems like I'm not writing very good. Okay, x, okay, plus 4x power 5 minus 2 over x plus 3 ln of x, and then we must plus 9x. But remember, you must plus c because we don't have a limit here, so we know the option number 1 is the correct answer. Let's go to the next question. Let's go to the next question. Very interesting question. So now let's go to the application of integration. Okay, let's do this one. This one is very interesting, yeah. Okay, excuse me. Application of integration. Look at this. They say the marginal cost. So you have your marginal cost, which is this one, marginal cost, MC marginal cost. Now they want to determine the total cost. Now, if you want to get your total cost, always integrate marginal cost and you're going to get total cost. That's all. Integrate your marginal cost and then it's going to give you total cost. Same total cost like that. It's just simple like that. So I'm going to say, well, if I want to get the total cost, I'm going to say, well, total cost equal TC, total cost. Okay, let me move this picture a little bit up. Okay, so then we're going to say, let me come back here. Now, so we have a lot of information here. We're going to say total cost we're looking for equal, let me do this one. I'm sorry. Total cost we're looking for equal to integral of the marginal cost. But what is the marginal cost? Negative 10 q power 4 plus 3 q squared plus 80 q. But then means when you integrate this marginal cost, remember it's going to be dq power. It's not power, it's just dq here at the end. Even they didn't give to you, but a clause dq. So what you're going to do here, we can integrate separately. So remember, total cost equal to integral of marginal cost. So we're going to start to integrate one by one separately. Now let's start with the first one. Integral 10 q power 4. Negative 10 is a constant. We're going to write q power 4 here, dq. So now this is going to become negative 10. We're going to take this. Q power 4 plus 1 is going to be q power 5. The same thing we write at the bottom. Negative 10 over 5 equal to negative 2. So this is going to negative 10 over 5 is equal to negative 2. So for the first one, it's going to give us negative 2 q power 5. So if you look at the answer, if let's say an exam, I know the third one is going to be the answer already because all of them, they have only that has a negative 2. Let's say in exam. So, the third one is the right answer. So we're going to say, okay, well, this is going to become negative 2 q power 5. Let's go to the second one. Integrate the second one. So when you integrate the second, it's going to be integral 3. I'll take 3 out, and here we're going to be left with q squared dq. So this, let me say 3, just a 3. Q squared plus 1 is going to be q power 3 over the same number which is here. We must write at the bottom. But 3 divided by 3 equal to 1. So let me say q power. So I'm going to say plus. And you can see the third option is promising. Let's go to the next one. Integral 8, but this 8 is going to go behind, right? You know the rules, right? Because constant. So the 80 is going to go behind 80. And this is going to become integral q dq. But there's no power here, means this is going to be power 1. So this, let me say 80, just 80. And the q, 1 plus 1 equal 2. But the same thing we must put at the same power, also put at the bottom. 80 divided by 2, 80 divided by 2 equal to 40. It's going to be 40 q squared. So I'm going to say plus, it's just a plus q squared. Let's go to the next one. Oh, we don't have a next one. But look, they say something here. Remember, you must plus constant. Why? Because we don't have a limit. But now we're not going to say C. You know why? Because they say they fix the cost, fix the constant. But now they give us the fixed cost is 1,000. So instead of me saying C, I'm going to say 1,000. And we know this is going to be the right answer. Let's go to the next option. Let's do the last question here. Let's do the last question quick. Sorry. Let me see which question you should do here. All the question we have to do. Oh, this is the one I just did it now. This one now. This one I want to do it. Let's do right here. This one. They say suppose marginal revenue. So this is marginal revenue, MR. Now they want to find total revenue. Oh, so we know the game. We know the game. We know how these people play. Okay, so then we're gonna say, well, we know how you. Okay, so if they give us marginal revenue, they want us to get total revenue is easy because I'm gonna say, well, if I want to get total revenue, they may say integral of marginal revenue. So if you want to get total of anything, integrate marginal. That's all. So wow, we're gonna say this same say let's come here. Integral of these. But here, I'm gonna put okay, let me right here. So it's gonna be integral of 300 minus 13 q plus 16 . Okay, let's start one by one now. So we want to say, well, let's start the first. So it's going to be integral of 300 dq because we must use this dq. For every integral, you must have a dq or dx or d whatever. Now we go. Remember, 300 is just a constant. So this may say 300 integral of dq. But like I told you before, if you have an integral of dx, that's equal to x. Integral of dm, that's equal to m. So integral of dq, that's equal to q. So it's going to be 300 q because this is going to be q. 300 q, 300 q. So the first one is going to be 300 q. The first one is going to be 300 q. Okay, 300 q the first one. So I can simply say the first one is 300 q. So if you look here, no, you cannot confirm it. Okay, let's go to the second one. So we're going to integrate 13q power 12, whatever. So that 13 is going to go behind. Because this one. 13 is constant, so I'm going to say 13 is going to go behind integral of q power 12 dq. So 13 is just 13, and then I'll take q. 12 plus 1 equals 13, so it's going to become 13 because we add 1 with 13. And the same thing, which is power here, we must write at the bottom. But here, look, this and this cancel, so this is q13. But there's a minus here, so we're going to say minus q13. Let's go for the next one. The next one is this one, 16q. 16q. Look, if you're watching, click the like button. I'll just click the like button. It's very, very important. It's very, very crucial. Very, very important. So we're going to say now integral of 16 q3 dq. So 16 is just a constant. So I'm going to write my 16 behind. I don't even have to write there. 16 integral. And then what we're going to do here, look, we're going to take this and then we add by 1. So we have a 16 q. 3 plus 1 equals 4. The same thing we must write at the bottom, 4. What is 16 divided by 4? Equal to 4. So this let me say 4 q power 4. So then I'm going to say, remember here there's a plus. So I'm going to say plus 4 q power 4. And you must plus constant. Okay, you must plus constant always because we don't have a limit. But for now, our constant we have here given 3316. So I'm going to say plus 3316. You don't want to write. But 33 plus 3316 there. Plus 3316. And that's going to be option number... No, it's not option number. Option number 3. Hey, my beautiful family. Look, if you're watching here, please click the like button, my beautiful family. Click that like button. Make sure you do that. Click like the like button. And hey, we can arrange for the next session very, very soon. Click the like button. And for the other one who are new, please, you can reach me inbox. We have many other classes that I will do privately. Okay, click the like button. And for some people who don't know, we have a lot of program apart from this. We have a lot of positive projects we do for the community, helping the homeless, feeding program. But feeding only cannot be enough, because when you feed a man, if you don't know how to fish, it then become problem. So we equip our brothers and sisters with the skills, especially programming skills, coding skills, learning programming, start entrepreneurship, that start their own business. Because when somebody or a vulnerable person start their own business, means they can employ themselves and create a job among themselves, and then they can change their own life and the loved ones. You see? So we have those programs. You can click the link below. You're gonna see some of the projects that I would do, feeding, helping the homeless. Also people with a mental illness with the little that we have. Thanks a lot for your time, and do not forget to click that like button. Don't be like my previous class, man. They were kind of like, listen, if you're watching here, you not click the like button, man, then you envious, man. Stop. Listen, man. Then you hater. Hater, don't click the like button. We know hater don't click the like button. I know you're not one of those. I know you're not one of those. Don't be the hater, man. Don't be like those people, like, they're kind of envious and hater, man. If you don't click the like button, then you're a hater. Because we know some people like that. Hey, thanks a lot for your time, my beautiful family. We're going to stop here for tonight. We know we have a groups on inbox, so we're going to discuss more. Thanks a lot for your time. The hater never click the like button. Envious and hater and jealous never click the like button, man. You know who you are, man. Thanks a lot for your time. Peace. And I'm going to see you all very soon. Peace, and we out.